So the big announcement today, the point of sale assignment is out, and we are starting object-oriented programming. We are officially in Learning Objective 2. So just a quick reminder that what we need from you, what I need to see out of you for each learning objective is in the syllabus. We are moving on to Learning Objective 2, which is really mostly about inheritance and polymorphism, and also references and heap space. So quite a few juicy topics to dive into, and to learn that. So today, my brain just isn't working there. Just didn't want to work. So today we need to learn what objects and specifically classes even are, so we can get into these topics: inheritance, polymorphism, heap space, heap memory. References should be explicit here. Well, it's part of stack and heap memory, so it's included in there. But references I should have named explicitly. So to this end, we want to work on this point of sale project. This will be what will consume a lot of your time during this learning objective. And what we want to do is build a self-checkout machine where a user can enter barcodes. We don't have a scanner for this, but the user will enter barcodes into this machine to determine what they want to purchase, and then be able to purchase those items. There are various features that we want to add to this. For example, having items be on sale, having items compute the proper sales tax, and loyalty card. Well, actually, that's an application objective, so some of you might not do that. But loyalty cards to have extra sales on top of the other sales. And I mean, somebody's got to have that in stock, though. Somebody can get these for $2,000. Just you got to be, I don't know, it's something special. And the big thing for this is the big caveat to this assignment is that we cannot use conditionals. No if, no else if, no else, no match case, no try, throw, catch, finally, because you can use those to simulate conditionals. No while loop, because you can use those to simulate conditionals. Same with do while. And in general, just any way that you can run part of your code conditionally on the value of a variable. So if you're saying if some condition, some value that I have stored somewhere is something, run this code, otherwise don't run that code, or otherwise run this code. If you're doing anything like that, anything to simulate an if statement, that is in violation of this assignment, and it should be a 0 on the entire assignment, and you got to fix your stuff. No conditionals. No conditionals at all in this assignment. You can use a for loop. And any of you familiar with previous versions of the OOP assignments, for loop used to be banned, so you can use for loops this semester. But you can't use anything to simulate a conditional. And I'll let you read through the rest of the document. There's tons of good, juicy stuff here. There is a lot. Don't get intimidated by it, because remember, this is all of the lecture objectives baked into one assignment or one document, plus all the application objectives. So one thing I want to point out, there are no... I messed up my terminology. They're called lecture tasks now. Just to avoid the confusion between lecture objective and learning objective, both being LOs. If we want to use the abbreviation LO, are we talking about learning objectives or lecture objectives? So they're lecture tasks now, so it's LT1, LT2, and then learning objective 2, LO2, refers to OOP. So anyway, there are no programming objectives on this assignment, and I'll probably stick with that. I'm probably just going to scrap programming objectives altogether. So there are 6 lecture tasks. Complete all of the lecture tasks, and you've completed the right portion of LO2, learning objective 2. No programming objectives for this project. Probably going to stick with that moving forward for the other 2 projects. And also, there are, if we can get there, 3 application objectives on this assignment. So you can get most of the way to an A after this assignment. Some of you will have 4 application objectives complete after this assignment, and you only got 2 more to do to earn your A. 3 application objectives. Now, I have to caution you, these are difficult. To do all 3 of them will take a significant amount of time unless you really have a strong grasp on the material. But the options are there. If you can get at least one of these, you're in good shape for the course. But if you don't get discouraged if you can't complete all 3 of them before the deadline, at least without spending a lot of time on them. But if you want the extra challenge, and especially if you want the freedom later in the semester, these application objectives are here for you. So there are 3 on this assignment. My goal is to average 2 per assignment. So this will even out only having 1 on the first assignment. And then the next 2, I plan to have 2 application objectives each. So you can get your application objectives just through the homeworks, even while skipping 2 of them. So if you only do 1 of these, or none of them even, you can still earn your A in the course. It's really up to you how to pick your path to an A with all these application objectives. You have a lot of freedom in choosing what you do. Or you can try to do them all and get it done. If you're struggling with anything, I would just forget about the application objectives, worry about them later in the semester, and get your lecture tasks done. Especially if you're not needing to get an A. If you're happy with a B or a C, don't even think about the application objectives unless you're comfortable with everything. Don't sacrifice a lecture task to get a learning objective, is what I'm saying there. Okay. So let's start teaching it how to do that assignment. And how the hell are we going to do that without conditionals? Which is a question we won't really answer until quite a bit later. How you're going to do the self-checkout part. For the first 4, maybe arguably 5 lecture tasks, they're set up in a way that you just don't need to make any decisions in your code. So everything can just run linearly. And we'll see how that works. Once we get to learning objective lecture, lecture task, I'll get through this day, I swear. Lecture task 6, that's when we have to start making decisions in our code without conditionals. And that's, you'll see we're going to use the state pattern. To learn the state pattern, we have to know what polymorphism is. To know what polymorphism is, we need to know what inheritance is. To know what inheritance is, we need to know what classes and objects are. So this is where we start, is with classes and objects. I didn't sleep that much. The whole weekend I was, getting your... Oh, by the way, I posted on Piazza, but all the lab results are released. A few of the TAs and I spent a lot of the weekend doing that, and then I spent a lot of time getting this assignment released, getting the document all in the shape that I want it to be in and everything, making sure that my solution works so I know there's no surprises coming up. I released documents too early before I had my solutions. Then I write my solutions and I realize the assignment's impossible. I don't want that kind of stuff happening at this point in my career. All right. Yeah, getting lit with work. I worked all weekend. It's weird. Whenever I work all weekend like that, Monday always feels like a Friday because I feel like the week should be ending because I'm already exhausted. So it's gonna be it'll be a tough week, but hopefully tonight I can catch up on some sleep and relaxation. And then tomorrow finish up the grader for project 2 and relax a bit. Anyway, we got some content to cover. We got some things to learn. Let's do this. So the first lecture task of the point of sale assignment is to create the item class. So as we're using this self-checkout machine, we're going to be purchasing items, and we want to be able to track information about those items. For this task, we're going to create an item class with a constructor, a word that you haven't heard yet that we'll learn about today. A constructor that takes a string representing the item's description and a double representing the item's price. And this is the base price. We actually already had this question in office hours. This is the base price of an item. When we do get to sales, that should not affect this price at all. This price is always going to stay the same. You can declare it with val if you want. This price will not change later on for those of you who are already ahead. A method named price that doesn't take any parameters and returns the price from the constructor, so just return this price. A method named description, which returns this description from the constructor. a method named, and two methods that go together, a method named scanned that doesn't take any parameters and returns unit. From the method header, it looks like it does nothing. But we're going to see how we can get it to do things. And a method named times scanned, which tells us how many times the scanned method has been called. And then testing, of course. Is the grader for this project is not released yet. Tomorrow it will be. Tomorrow I'll get that done. Get that released. So this is our first task. We need to create this item class, and this is what people will be able to purchase from our store. A few things I want to point out with this. One, a constructor. We don't know what that is yet. So writing this constructor, it is a method, but it's a special method associated with classes. So we need to learn how to write that. This method that returns unit, this doesn't take any parameters and doesn't return anything, but it still has to affect the item itself. We have to track how many times this has been called. So how do we do that? And these, more of a testing note, these parameters in the constructor do not have names in the documentation. Nowhere in the point of sale documentation are these variables given any names. The names are not defined. Whenever this is the case, that implies that you cannot access those variables in your tests, because you're going to name them something. In my solutions on Autolab, I'm going to name them most likely something different. So if you're accessing those variables in your tests, once your tests are ran against my code, your tests are going to have errors in them because you're trying to access variables that don't exist. You're getting a variable not found exception, and you're going to get the slant, the kind of puzzled, concerned face in Autolab because your tests crash when ran on my code. You can only test things that have been clearly defined. The item class has a clear name, item. The price method, the description method, the scan method, the time scan method. These all have clearly defined names in the documentation. So that means you can test those. You can have those in your tests, and I can have those in my tests. Neither of us can test anything outside of those. So in my testing on Autolab, I cannot access your description or price directly. I have to access them through these method calls. So that's always the case. I'll repeat this a lot throughout the semester. It's a pretty common mistake that students make, is anything that's not defined, anything that you named that I didn't tell you what the name is, you can't access those in your testing because that's going to break in Autolab. So just a cautionary, caution there. And sometimes I'll purposely not name things. Like I purposely didn't name these two things because I don't want you testing through those, because we want to be able to test using classes and objects and the concepts therein. You don't really get that as much when you just access these directly. All right. So let's talk about objects a little bit. This is what we've been working with the entire time so far in this class, is only objects. So let's give a quick brief summary of objects and show one new thing with objects that have state, and then we'll move into classes very quickly. We'll get into classes. So objects have state and behavior. An object is a way to encapsulate. It's like one big package, or even a data structure, if you want to think of it that way, that has named variables and named functions defining the state of all their variables and the behavior. How does this object behave through all of its functions? And when we have a function that's part of an object, we do call it a method. There is a slight difference between methods and functions. So an object has variables and methods. That is what an object is. It's a collection of variables and methods. So here's an object with variables and methods. A lot of the objects we've seen have only had methods. So let's see one with some state, with some variables in it. So here's an object with some state variables. And what we do to have these state variables, these variables contained in our object, is to declare these variables outside of any of the methods. That puts these variables in the scope of the object itself and not in any specific method call. So these are going to live beyond any stack frame that's created through a method call. It's going to live with the object itself. They're not quite global variables because they're local to the object, but they are more global than the variables in a stack frame, which I don't know if I use this vocab, but if we declare a variable inside a method, we call that a local variable. It only exists locally inside that method. These are going to be called, I'm going to call them state variables. They're going to determine the state of a particular object, but they can't be accessed. Their global variables would be outside any objects at the program level. We actually don't have those in Scala because they're generally bad practice. So we put variables outside of all the methods, and then inside our methods, we can access them using the this keyword. This, and then the dot operator, we're going to be able to access any variable or method of an object. So here I'm doing this dot x to access this variable x, and then multiplying it by 2 and reassigning it to itself. Yeah, you can still declare a variable named x inside this method. So the keyword this, I'll mention this right away, I guess. The keyword this is usually optional. You can just do x times equals 2, and Scala will know that you mean this x, because it's the only x in scope. You can also have a local variable named x or a parameter named x inside this method. And in that case, if you just say x without the this, you're going to get the local x. But you can still access the state variable x by doing this.x. This.x will refer to the state variable, and then just x will refer to the local variable. So you can actually access this x even when there's another x that would be blocking its scope. You won't see me do public or private in Scala. Actually, I used to have a slide talking about that. I removed the slide entirely these days. There are some things like public and private that we'll talk about, but we won't use those keywords. I won't use them in the class at all. And there are reasons for that. I used to get into it. I don't get into it anymore. It's only useful for those of you coming from Java or C++, and only if you really understand what the public and private were. There are reasons why we don't need to use public and private in Scala, but so I'll just leave it at that. Usually in Java, you keep your state variables all private, and then you have getters and setters to modify them, and those getters and setters are public, and the variables are always private. There's a good reason why Java does that. There's a good reason why Scala doesn't. We don't need to get into it during lecture time, though, but there are reasons for that. What's the difference between function and method? A method, everything you'll see until learning objective 3 is going to be a method. Methods are like functions, but they're attached to an object. They're part of an object's behavior. Function, you haven't seen any functions yet. We won't see functions until we get to functional programming. We won't be using getters and setters, nope. No, that's a Java thing. Scala has something built into the language that gets around the need for getters and setters. I'd be happy to talk about it, but after lecture we can get into detail. All right, so these state variables, they go by many different names. I'm going to use the name state variable, but if you've ever heard of instance variables, member variables, fields, various other names, if you skipped the list. I don't think I had anything to talk about. Yeah, we've talked about this before, val and var, but just a quick reminder. I just wanted that reminder up there. I used to not talk about that until I talked about objects, but I talked about that earlier in the semester this time. Var, the variable can be reassigned. Val can't be reassigned. So you may have heard these, if you've dealt with objects before, you've heard of these probably by different names. I'm going to use the name state variable. I think it's the most descriptive name because these variables determine the current state of that object. This x is 10 and y is 7 defines the current state of this object. That object is in the x equals 10, y equals 7 state, and that's going to determine its behavior. In this case, not so much because it's just a toy class for lecture, but that will determine its behavior. To access an object's state or behavior, we call the object by name or a reference. This is a reference to the object. and we access its state and behavior using the dot operator. So we have object with state. This is an object, so we're going to call it by name, and then call its double x method and access its x state variable using that dot operator. And we've seen this syntax before. We've used it with strings. We use it with lists to call like dot split on a string, to call dot length on a list, dot apply on a list. We've seen these before. We've had objects with behavior in its methods, and then we call those methods, we access its variables. So we can do this with our own objects as well. And we can actually change the state of an object. This call of object with state dot double x, we're going to call this double x method, which doesn't take any parameters and returns unit, something that kind of looks like at first glance it should do nothing at all. But in fact, it does modify the state of the object. So I'm a little more terminology. It's something we call a method with side effects. The side effect of calling this method is that the value of x will be doubled. So after calling this method, the state has been changed. The state variable x is now the value 20. And then when we print out object with state.x, we access this x, which this is where anyone coming from Java starts panicking and going into a cold sweat. Yes, we are accessing that variable directly, not through a getter. And when we access that x, it's going to have the value 20 because its state has been changed through this method call. Yeah, we can retrieve x right from the main method. That's what we're doing right here. .x, we're just saying, give me the value of the variable x in this object with state object. Okay, I'm good on that. Are these objects in the same file? They can be. I believe these should be in the repo, and I'm not remembering. Yeah, I have them right. I have them in different files, but they could be in the same file. You can, technically, you can put your whole project in the same file, or every class in the same package in the same file. And I believe you can even annotate to say put these in a different package, put your whole project in the same file. As a general practice, generally good practice, every object and class with a different name should be in a different file. For example, we could have a class and object both with the name object with state. That specific example doesn't make sense, but those would go in the same file. But once we have two objects or classes with different names, we put them in different files. Just as a general, sometimes I break that even when it makes sense to, but as a general rule. But they could be, but they don't have to be. It's a matter of style in convention. If you ran these two lines of code a second time, would it be, it would do the same thing. Since this is a main method, that would restart the entire program. It would reinitialize object with state, and it would double 10 up to 20 and print 20. If I ran the program again, x is again 10 because the program just started, everything's reinitialized, and then I would double it to 20 and print 20 again. If this were a method, and then I called that method in main 2 separate times, then it would go up to 40. But since this is a main method, it has to restart the whole program. No memory persists after the program ends. All memory is freed up. It's all gone. So when we restart the program, that 20 has been deleted, and we start over again. Root value in Scala is an object. This might not mean a ton to you yet, but it should by the end of the semester, if not pretty soon. The reason this matters to you right now is that no matter what value you have in Scala, and no matter what it is, if it's a literal value, like just the number 5, or a string, a literal string with double quotes around it, or a variable, or a variable that's a parameter, no matter what it is, no matter what you have, in Scala, it's an object, which means you can use the dot operator to access its state and behavior. So no matter what you have, if you have something in Scala, it's an object, in IntelliJ, hit dot, and you can see all of the state and behavior in that object. So you can see the methods that you can call. If you have a string, just hit dot, and IntelliJ will say, here are all the string methods. There's length, split, contains, to lower, to uppercase, all kinds of nice methods that you can access. Or access the underlying array of bytes in the string if you want to get into the raw data and access that stuff directly, you can do that too. So all kinds of stuff. Math.py, we accessed part of the state, one of the state variables of the math object. Pi, which is a constant, it's a val, it's oh, never mind. It's a Java class, so it's not val, but it's the equivalent in Java, const. So we can access those from anything. If you have an integer, like if you have the value 5, you just type 5 in IntelliJ and then dot, you'll see all the integer methods that you can call on that. And in the handout code, if any of you who really dug through already, in one of my GUI classes that I provide, I use 0.max to use the max method instead of math.max. I'll call the max method that's contained in the integer class and call it right through the literal value 0. Since it's a thing in Scala, it's an object and it has state and behavior. Now let's talk about classes. This is what we really want to talk about these days. We're moving on beyond objects. That's what we did for so far in the class. Classes are where it's at now. What classes are templates that are used to create multiple objects. We use a class to instantiate a new object using the keyword new, or if you don't want to remember this big word, we create new objects using classes using the keyword new. When we create a class, we're defining a brand new type in Scala. So we've had types. We have int, double, string, list, map. We've seen a lot of types already. With classes, we're going to define our own types that can be used just like any of the types that we've seen. We can have variables of the type. We can have methods that take that type as a parameter. We have methods that return that type. We can have a data structure of that type. We can do anything we can with any other type, but we're going to define our very own types. So let's see an example of this. We're going to create a player class. This player will have 4 features. This player will have a location on some XY coordinate system. It will have some fixed amount of max hit points that can be different between each player, the current hit points of that player, and the ability to damage other players. So a little bit of functionality, but we want to see how to create a class. A class, which is a template to create objects, where we can create multiple player objects, each with their own XY location, their own max hit points, their own current hit points, and their own behavior of being able to damage another player. So we want multiple players with these behaviors and state, and we're going to create a class which is going to let us do that, create multiple objects of the same type, a new type player. So let's jump into some code. We're going to go through this one bit at a time. I'm going to pick this apart and show you what it does. I won't explain all the little things like we know what subtracting something does, for example, and adding something. But I do want to explain all of the new things that we're going to see here. So this is our player class. We have an X and Y location on a grid as doubles, max hit points, which is a val, so that's never going to change. The current hit points initialized to the max hit points. The amount of damage we can deal to another player. You can probably kind of read through this code, but I want to explain this to the level where you can write your own classes because, hey, that's what you got to do for your lecture test today. You have to write your own item class with its own state and behavior. So let's get you to that point. So let's pick this apart and talk about each of these things. So we can see the state in this class. We have 5 different variables. I'm using that interchangeably, variable and value. 2 of them happen to be values, but 5 different variables that are going to define the state of a particular player. A particular player is going to have a location, an X and Y location, the max hit points, the damage that they can deal, and their current HP. I guess I just went through those, didn't But this is the state of a player. So this class is going to say, I don't know what your player objects are going to do out there, but I know that they're going to have their own XY location, their own HP, their own damage, and their own max hit points. So those are all the variables that will define the state of a player object, which will be created through this class. Along with state, we have behavior. So we have 4 methods here that can be called from any player object. Any player that we create using this class is going to be able to have these methods called. If we have access to a player object, we're going to be able to say player.take damage, player.attack, player.conscious, player.move. We can call these methods with any player object that we have. Just like if we have a string, we have a variable that stores a string object. We can say string.length, string.split, string.starts with, string.contains. Same thing here. We're going to define the methods that someone can call on an object of type player. So if somebody has a variable that stores a player object, they can be like dot take damage. They can call these methods on that object. I'm going to put all 5 in the parameter. I want to show you that you can do both of these. There are cases where you're going to want to do this. Even in your item class, even in your item class for today's lecture question, you'll want to split these up. So anything you put in the I haven't defined constructor yet. You know what? I'll talk about that when I get to it, because I don't think I put a bullet point. Oh, it's right here. I don't think I put a bullet point on that specifically, why I split these up. And it's a good question. It's a good point. I got to talk about that. So each class has a special method called a constructor, which is going to be called to create objects of this type. So to create a new object of type player, we're going to call this constructor method with these parameters. So whenever you create a player, you'll have to specify through the parameters, with these parameters of the constructor, the X location, the Y location, and max hit points. So whenever you create a player, I'm saying if you want to create a player, you have to tell me where this player's starting location is and what their max hit points are going to be. You have to supply those 3 pieces of information to create a new player class. Now I also have more state variables that I didn't put in the constructor. These are the state variables that I don't need the creator of this player, to initialize. So HP is a great example here. HP I don't want to be initialized in the constructor. You're going to tell me the max hit points, and every single player that's created, their hit points are going to start at the maximum value for their hit points. Every player, we're going to say in this imaginary game that every player is going to start at max health when they're first created. So we're always going to start at max health, and every player in this game is always going to deal 4 damage when they attack. So I'm saying these, since they're not in the constructor, are not variables that you get to initialize, but any variable that I want to be initialized, I'll put that in the constructor. Players can start in different locations, and players might have different max hit points from each other. I'm using val and var here. We've seen this before. Var means that the X and Y location can change because this player can move around in the game space. I want those to be able to change. And in fact, I change it in the move method. I'm going to allow the player to move around in this game world. The max hit points, I don't want that to ever change. We're not going to have, so I'm saying we're not going to have level ups or anything. The max hit points is always going to be the same value. So I'm going to say that's a val. We can't change the max hit points. There is a third option when it comes to constructors, and one that we have to be pretty careful about. We can leave off val and var and don't do anything. Like if we left off val and just did max hit points of type int, like this were a regular method call, a regular method, we can still do that. The the parameter will default to val, so it cannot be changed, and it can't be accessed from outside the class. So if you have a variable that you want to be able to access from outside the class, say in your testing methods, they have to be either val or var, depending on whether they should change or not. If you forget to put those or you don't put those, you're not going to be able to access your variables from your testing, which is sometimes what we want. Like max hit points, for example, we could leave off val here because we might not want to access, we're never going to want to access that directly. We know what it is because we call the constructor and it's never going to change, so we know what it's going to be. But we put the val here so we can't access it outside of this class. And we use the keyword this a lot in here. We saw this briefly with the object example, but the keyword this is going to always store a reference to the current object, which what is the current object? That'll make more sense over the next two lectures when we talk about heap space and references. The current object is often the calling object. So if somebody calls the take damage method, this is always a reference to the object through which the take damage method was called. So it's going to be a reference to that object. So this.hp is the object's HP through which the take damage method was called, which is usually what we want. In this case, anyway, if somebody says, hey, player object dot take damage of 5, they want to reduce the HP of that object that they called that method from. And then that object's HP is going to be lowered, their state is altered, their HP is less than what it used to be. Once we define our class, we have our new class here, we have a brand new type in Scala. So we can do whatever we can do with other types, with doubles, with ints. We can do the same things we can do with those types. As we can do the same things with our objects, with our class, as we can do with those other types. So we created a type player. That means we can have variables that store objects of type player. We can have methods like this one with a parameter of type player. We can have methods that return objects of type player. Anything we can do with like a double or an int, we have the same capabilities with our new type. So we've defined a brand new type in Scala. We can do all the stuff that we can do with other types. We could even have other classes that take an object of type player as one of its constructor parameters. We can do anything we can do with other types. We've created our own type in Scala. We have static classes in Scala. Static classes is effectively objects. Java static classes, effectively objects in Scala. Because there can only be one. It's like a singleton. Both of those concepts. So, any questions on... Oh, actually, I only got 10 minutes. But any quick questions on this one? Let me try to catch up with chat a little. Minecraft does have Z. I almost put XYZ. I just didn't want more clutter on the slide. To have a 3-dimensional space. So I'm thinking of like a top-down view of a 2D game. Yeah, 0 is an object of type int. Yes. Like if I just type like this 0 right here, I could type dot ABS, for example, on it. Obviously being 0, that wouldn't do anything, but you get the idea. I can access variables right here through this object of type int. Of capital I. A nuance point, but of capital I. Lowercase I int is a Java thing that's a primitive. Which if you don't know what that means, just forget I said it. So now that we have our class, let's create objects of this type. And for that, we're going to use the keyword new and call the constructor. So the name of the constructor method is the same as the name of the class. So I'm going to say new and then call the constructor and give it those 3 parameters that we expect. So we give it 3 arguments. Those arguments match the parameters. So X location, Y location, max hit points. X location, Y location, max hit points. So I'm calling that constructor and initializing those 3 state variables in this new object. And then the constructor is going to return, for today's lecture, I might keep saying object. It returns an object of type player, which we're going to store in a variable. Over the next 2 lectures, we'll see it actually returns a reference to that object. So we'll clarify that over the next 2 lectures. But for now, let's focus on classes and objects. This is going to return a player object, and we're going to store that in a variable. So we've created a new object, 2 new objects of type player, and stored them in these variables of type player, and named them just player 1 and player 2 because I couldn't think of anything more creative. I should have just named them Mario and Luigi. If we're going with the 2D game, I don't know. We put a main method in a class. No, you can't run it. Main methods have to be in objects. So if you have a class and you want to test it with a main, in the same file, create an object of the same name as your class and then put a main method in it, and you can test it. Or do the better thing and just write unit tests and skip the main method completely. You don't really need main methods anymore these days. Write your unit tests. Type and class have to be the same. So when we say type, what we mean is that there's a class with that name. Class and type are pretty synonymous. So we create new objects of our type, and then we get to do all the things that we do with objects. We can call its behavior. So we're moving player 2 from its initial position. We're going to move player 2 to a new position, update its X and Y location through that method call. And we can access the state variables. Call these methods, access the state variables. Here we're calling player2.attack. The attack method takes a player as a parameter. So we're going to give it player 1 and let it attack player 1 a couple times. And then we can check in our testing, is player 1's HP what I expect? I would expect it to be 2. If it started with 10 max HP, should start at full health. Got attacked twice for 4 damage each. HP should be 2. And I can make sure that that's what I expect it to be. I still don't get the assert, though. Oh. At all? Have you done some pale blue dot? The assert is saying, is the value of player 1's HP equal to 2 at this point? So each time we have attack here, attack should be calling the other player's take damage method and reducing their HP by the damage dealt. Damage dealt is always 4 for every player. I just have that as a hard-coded constant. Damage dealt is always 4. So when I call player2.attack of player 1, other player here is assigned player 1. So other player.take damage is the same as saying player 1.take damage in my main method. So player 1 is taking 4 damage, calling player 1's take damage method with 4 and decreasing its HP by 4 each time. We call it twice. So player 1 got damaged by 4 2 times. So we expect its HP. With a player class that's implemented the way we expect it to behave, player 1's HP should be equal to 2 at this point. Because it started at 10 max HP, took 4 damage, that should be 2. Will the location of player 2 change to player 1 while attacking? No. I mean, it could. We could add that functionality, but based on the code that we've written, it's not going to happen. But we could add that. We can have knockbacks and all kinds of nice features. None of that exists right now. So we've written our own class. We've written our player class. This is the same thing that's been done for int, double, boolean, list, array, map. All the objects that we've seen, all the types that we've seen so far, all have classes like this defined in the Scala standard library. So in the Scala library, there's class somewhere in there is class list, and then a constructor, and then the definition of a list with all of its state and behavior. Same thing that we're doing here. One slight difference, just the way that they're set up. They have companion objects with apply methods for what it's worth. But when we call the constructor for a list, we don't use the keyword new. That's just the way it's set up. We could set it up the same way. We probably won't at all in this class. We're always going to use the keyword new to create objects of our types that we create. But we've played with classes before. We've been using them all along. We just haven't defined our own classes yet. That's what we're doing new today. So for the lecture task, create an object of type item, has a constructor that takes a string and a double, a method named price that returns that method's price and description that return the price and description from the constructor. So when somebody says new item, price and description, and then says item, whatever the variable name they stored it in, dot price, that should return whatever price that programmer gave to that constructor call. Same with description. And then scanned and time scanned, the scanned method doesn't, appears to not really do anything. But when we call time scanned, we need to return how many times scanned has been called. For this, you're going to want a third variable that does not appear in the constructor. You're going to have this third variable outside of all the methods, so it's still a state variable, but not in the constructor call because we don't want to initialize this. This should always be initialized to 0. The number of times scanned when you create a new item is 0. It's never been scanned before. And then every time you scan it, you'll update that state variable, and then time scanned is going to return the current value of that state variable. So we effectively have information that's going to be shared across methods and across method calls. That's what our state is giving us. So this time scanned method is going to behave differently depending on the state of the object, because its state variable that's remembering how many times scanned has been called is going to be changing throughout the lifetime of that object. Quick lecture. I mean, it's always 50 minutes. But yeah, it might it's not over yet, but I think I spent too long talking about the homework at the beginning. I used up 10 minutes there. And we can test this thing. So I have this code. You can look at it more in depth in the repo, or I'll probably keep talking about it after the official end of lecture. But we have some methods that I'm going to use to help my testing. Of course, compare doubles that we've seen tons of times by now. A print player location method that's going to give me a nice formatted string, which tells me where this player is at this current point in time. A check player location. This is something you might want to start doing in your testing as the testing starts getting more complex. Check player location is going to take a player, an expected X and an expected Y, and then take care of some of the logistics for me. It's going to have my two asserts, calling compare doubles, and then comparing the X and Y locations. So I don't have to duplicate this code every time I want to check where player is. Every time I want to assert, is the player where I expect? I'm just going to call this method and let this method take care of it. Since player is a type, I can have methods that take a player. So I'm going to take advantage of that. And assert, this method is part of the class itself. So I can call that in my helper methods. I don't have to call assert inside my test. I can call it in helper methods like this. And then for testing, I'm going to create two players. I'm just going to print their locations. Actually, let me run this first, just so we can see what's going on. I'm just going to print their locations just to visualize it. This will help me in my debugging process. It's not an actual test or part of the test, but I'm going to do that in my debugging process just so I can see, if things are checking out the way I want them to. And we can see it does check out. Player is at location, player 1 is at location 0, 0, player 2 is at location 7, -4. And I'm going to check the player locations and make sure that this is the actual part of the test. I'm going to call my method, player 1 better be at 0, 0, player 2 better be at 7, -4, give or take truncation errors. I'm going to move player 2 and check its location. If I move it negative 6.5 in the x direction and 3.4 in the y direction, I expect this, since this is the starting location, moved by this dx dy, I expect this to be player 2's new location. So I'm going to call check player location. Player 2 better be there within truncation errors, or I'm in trouble. My test should fail and let me know that I messed something up. And since player 2 is right next to player 1 at this point, player 2 is going to start beating on player 1 a bit. This is the same thing that we saw in the slides. And then after being hit twice, I expect player 1's HP to be 2. And I expect player 1 to still be conscious. Their HP didn't reach 0 yet, so player 1 is still conscious. But player 2 is not going to let up. Player 2 attacks one more time. HP will be negative 2. Player 1 certainly conscious, so assert that player 1 is not conscious. So player 2 just lost that round or whatever they're playing. So this is how we can test objects. We want to call the methods. We're calling, for example, the move method that returns unit. How do we test a method that returns unit? There's nothing returned. So what we do is call the method, and then whatever we expect this new state to be, this method has side effects. It changes the state. Whatever the new state is that we expect, we're going to check that state by accessing the state variables and making sure those variables have the values that we expect after that method has been called.